So yes, you may have seen this. This is known as a battery. And you've probably seen it in most smartphones today. But they come in two forms. Either a rechargeable battery, a normal battery, or something which looks like this. A Samsung battery that's usually in your smartphone. But basically, this Samsung battery and the one on the right, the Energizer battery, has basically no difference. They're basically the same concept. And with only a small few tweaks, they've managed to put all that electricity and cram it into that tiny battery, which is known as mAh. Or this mAh is basically the capacity of a battery. For example, let's say one mAh is one person, and this battery on the right can store, 3,000 people or 3,000 mAh. On the left, the Samsung battery can store 2,600 mAh or 2,600 people. But how can the Samsung battery be smaller and store as much people or electricity as the one on the right, the Energizer? Well, basically, what the one on the left does is it takes its people and it shrinks them. It makes them smaller, and it makes them smaller, and it basically stores them in a more strategic way, which makes it so it doesn't really store that much energy. So it does store that much energy, and the Samsung battery is high tech, since batteries like these on the right were discovered and made in the 80s and 90s, while these things over here were only made recently, around the middle of the 2000s, when people actually started using this type of technology. So yes. Well, let's take a look at the history of batteries. So yes, this is the world's first battery. And it may not look like much, but it was the start of the revolution. The invention of the battery, as we know it, is credited to the Italian scientist Alessandro Volta. That's why we use electricity as volts. It was named after his last name, Volta, who put together the first battery to prove the point to another Italian scientist, Luigi Galvani, who thought that electricity came from animals, but Alessandro Volta proved him wrong by telling him that the electricity actually came from the metal and not the frog's legs. Galvani had shown that the legs of frogs hanging on the iron breast would twitch when touched with the probe of some metal. He believed that this was caused by electricity within the frogs. He called it animal electricity. But Volta was originally thought that he was really smart, and that was the correct way. But after putting a little bit more thought into it, he proved him wrong. But actually, he thought the electricity came not from the frog's tissues, but from the metal. This is what it's shown here. There's a layer of silver and zinc, interspread or cut in the middle with layers of cloth or even paper soaked in salt water. He thought, but when he put this, the electricity actually flowed from the the zinc to the copper. He thought that's what happens, but really, what was making the difference here is that he thought that the metal was the one that was making the electricity or causing the reaction, but in reality, it was the cloth that was making the zinc transfer its electrons to the copper. So yes, but mainly we credit him for the invention of the battery. Volta also found that by using different metals in the pile, the amount of voltage could be increased. He described his findings in a letter to Joseph Banks, the president of Royal Society of London, in 1800. So yes, this was the battery itself and its form. Napoleon was impressed, very impressed. So it was actually the layer of zinc and silver that was indeed twitching the frog's legs. So yes, here's a close-up. There's the iron rod, or the separator like the cloth, that the iron rod is a more efficient way to split the copper and the bronze, or the whatever you could call it, together. There's added ways the asphalt plugs, or the thing that transfers the energy, and then the vase, or whatever it's stored in. And this is a redefined version of his creation. Or, as you can see, there's the copper, and then there's the zinc. And in the middle, there's a wire running between them. So yes, this is basically it. So yes, this is it. So let's say you put salty paper and silver and zinc. What happens is the wire, it takes the energy or from the silver and transfers to the zinc. But, well, it's kind of like magnets. This is the South Pole, this is the North Pole. If you put those two together, they attract. But if you put the South Pole and the South Pole together, they repel. That's basically the same concept shown here. The silver attracts the zinc, but is not able to connect because of the salty paper. So, when connected a wire, the energy from the silver it's transferred to the zinc. But if you put something like a battery in here, in the middle, if you put a battery here, electricity will flow through the battery and then go to the zinc. That way we have energy. That's how energy for our electric cars, RC cars. There's a little motor connected here, and when the electricity goes to the motor spins as though the car's wheel spins. So yes, this is basically it. And this is a better solution. This is the chemical solution version, and this is another example. But hey, if you're asking, well, if all the zinc goes to the copper, or all the energy has been transferred to the copper successfully, then won't the battery die? Yes. That is why scientists came up with the solution of rechargeable batteries. So, this is another way. Rechargeable batteries. So yes, you connect that thing here, and what happens is, and it basically reverses it. So all the energy that's gone will be put back into the zinc from the retractor from the copper all the way to the zinc again. Therefore, the cycle. When you charge your thing or with your battery, all the energy in the copper will go back to the zinc. And when you use your battery, all the energy from the zinc will go back to the copper. But you can't do this forever, since after 10 years your battery will most likely die. And yeah, this is basically a better slope version. And then, in order to reduce oxidation, scientists put a thin layer over it, or a metal layer over it, so it could more efficiently transfer the energy. So yes, thank you.